Okay, let's look at the homework 6.4, problem number 9, right? So this kind of a triangular cylindrical tank is full of water, and we're going to basically pump all the water out, and we want to know how much work required to do that. Alright, so let's do that. Alright, so first thing is we have to kind of put the frame of reference. I would probably put the maybe axis, x-axis right here. Right, so here's the x-axis, and I'm gonna put the y-axis right here. Alright, and here's the origin. Right, so I'm gonna start with let's see, a random y. So here, random y. Right, then we're going to look at the approximating box. So it's going to be here. It'll look like a box shape body of water. Right, maybe I'm going to call it the YI star. Sorry, you can't really see this. Alright, so let's find the volume of this thing. Right, so volume, I'm going to call it the VI, is going to be, alright, so if you look at this triangle, and maybe if you kind of blow it up, alright, then we're talking about the red one. Maybe I should use a red here, right? And here, height is at y, yi, maybe I should say. So right here is yi star, and height is a in this case is 4, so from here to there would be 4, and let's see, b is also 4 too, so this is 4. Right, so this big one corresponds to this side, triangular side, and this smaller triangle is using that yi star there. Right, then if you pull out this smaller triangle, you see that these two triangles are a similar triangle, right? And the height is yi star. Those two guys are similar, right? Then we can use a ratio. Look at the ratio of the base and height. It's 4 to 4, so it's 1 to 1 ratio. So if the height is yi star, this is going to be actually conveniently yi star as well. Alright, so which means that we can find the volume. Right, so length here is yi star, right? Then length here is c is 18, so times 18, and times width is, or thickness is, delta y. Right, so that's the volume of that, like a box of water. Right, then we're going to turn it into a mass. Then we would have to use the density of water, which is 1,000 kilogram per cubic meters. So multiply by that to get the mass. Mass of that piece is going to be 1,000 times bi. So I'm going to incorporate 18, so 18,000 yi star delta y. Right, then if you want to turn it into a force, all you have to do is mi times g, which is 9.8 meters per square second. So Fi, force I, is going to be let's see, 9.8 times, I can't do that, so I'm going to just say 9.8 times 18,000 yi star delta y. Right, so we have that. Then maybe we should simplify that, so it's I'm going to use one of the zeros, so it becomes 98, so it's going to be 1800. So if you do a multiplication, 2 zeros, 8 times 8 is 64, and 8 times 9 is 72, so 78 here. and 1, so it's going to be 98. So it's going to be 004 671, right? So this is going to be 176400. Then you have a yi star and the delta y. Alright, so that's the force by this, the box full of water. Alright, then what we need to do is we want to bring it up to this level here, which is, let's see, A is 4, D is 2. So at this point, this is the, we have to go up to 6, right? So this distance it needs to travel to get up to here would be the difference between 6 and yi. So the distance, so we can find the work. Oops, let's use a different color. Right, work just for that piece is going to be force, which is this guy, 176400, and yi star delta y. Then you need to multiply by difference between 6 and yi star. Alright, then all you have to do is, to get the total work, we just need to add them up. So you have a summation. I goes from 1 to n. Then you have a 176400 yi star. Then I'm going to put the 6 minus yi star and the delta y. Right? So therefore, we have an integral. Right? We can easily turn this into an integral. So I'm going to just get rid of that one. Then the integral work can be found, right? Integral, right? The water goes from 0 is the bottom of bottom, and the top is a, so it's 4, right? Then we have this, so 176400, and then I'm gonna have a y, and a 6 minus y, delta y becomes dy, right? So let's clean it up and define the integral. So I'm gonna put the 176400 in front of the integral, so you have an integral from 0 to 4, and I'm gonna distribute the y to 6 and the negative y, which is gonna give us 6y minus y squared and dy. Right? So let's integrate that. So 176400. Alright, antiderivative is, let's see, y squared over 2, so it's 3y squared, minus antiderivative of y squared would be y cubed over 3. Then you are going from 0 to 4. Right? So this is going to be 176400, and plugging 4, you're gonna get, let's see, 4 squared, so 16. 16 times 3 is 48. Minus, put the 4 cubed would be 16 times 4, 64, right? So minus 64 over 3, right? And taking a common denominator, right, we get the 3 here, right? So 48 over 3, so we have to multiply by 3. So 24, 3 times 8 is 24, 3 times 4 is 12, so 144 minus 64, right? So we're going to get 176400, right, 3, and then you have 64, so that will be 80, right? So then if you multiply out, you're going to get, so you have 3 zeros, and 8 times 4, 32, and 6 times 8, 48, so 51, and 7 times 8, 56, and then 1 times 8 is 8, so 41, right? So we get the answer Alright, so it's going to be, this is going to be the work. So in joule. Alright, so let's type this guy in. So it's going to be, let's see, is it the 14? I forgot it, 1411200. Alright, so let's type it in. Alright, so we have 1411200. Is that right? Alright, 1411200. Alright, so let's go back. Alright, let's submit for testing. Alright, I forgot to do over 3, so I do put divide by 3. Right? So let's right, so here. Right, so divide by 3. Right? So let's check the answer. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.